Hello friends, welcome to Physics with Ben. Don't forget to subscribe, like, comment and share this video to those that need it. In today's class, I want us to look at calculations on vectors in physics. You may love to click in the description box below to find the video links on the other video series that I have done on scalar and vector quantities. Without wasting much time, let us go straight to the business of the day. Question number 1. An object is acted upon by two forces of magnitudes 5 Newton and 12 Newton respectively. Calculate the resultant of the two forces if A. The two forces act perpendicular to each other. B. The two forces act at an angle of 45 degrees to each other. C. The two forces act at an angle of 125 degrees to each other. Solution. So we are going to start with A. First off, we are going to sketch the diagram for this information. One of the forces is of magnitude 5 Newton and the other force is of magnitude 12 Newton. So the next thing, these forces are acting at an angle 90 degrees. That is what we mean by they are perpendicular to each other. So we're gonna draw this line to represent the resultant vector. And then we are going to complete the rectangle. Knowing that up here is also 12 Newton and also here is also 5 Newton. So right now we are going to, let's take this as our force 1 and this as our force 2 and this as our force. Now, I told us in the other videos that when vectors are acting at right angles to each other, we apply the Pythagoras theory. Recall that in mathematics, you have it as a squared is equals to b squared plus c squared. Yeah, where your a is equals to the root of b squared plus, the root of b squared plus c squared. We are going to apply this principle here in physics in solving this question. And so we have it as f squared is equals to f1 squared plus f2 squared. That is an equation. The next thing we have to substitute our f1 squared is 5 square. Our f1 is 5, so we'll square the 5, and then the other one is 12 square. So 5 square will give you 25, and then 25 plus 12 square, we have 144. So if you add this up, you're gonna have 169. So we write that f squared times the index of 1 all over 2 is equals to bracket 169 times the index of 1 all over 2. This will go, and this is the same thing as the root of 169. So if we do that correctly, we write that therefore our resultant force is equals to the root of 169 will give us 13. So our resultant force is 13 Newton. As simple as ABC. So for this, our resultant force is 13 Newton, the longest line. That is the answer to that. The next thing they ask us to do is to calculate for B that the two forces act at an angle of 40 degrees to each other. That is an acute angle. So B says the two forces act at an angle of 40 degrees to each other. So the forces, the magnitude of the forces remains 5 Newton, and then the other one 12 Newton. Yeah. Now, this is where we apply cosine or the sine rule. So the next thing we got to do is to draw the diagonal from the point of intersection here. Good. That is our diagonal. And so we complete the parallelogram. Good. Recall that the parallel sides of the parallelogram, they are the same. So this side is same with this side. So up here we also have 12 Newton. And then here we also have 5 Newton. And at the opposite angles of the parallelogram, they are also the same. So the forces, they are acting at 40 degrees to each other. This time we'll have this angle with us. Let's call it angle alpha. And then this angle is also 40 degrees. So the sum of the angles, this angle is what we are interested in. And then this is the resultant, our F, that we are looking for. So we know that the sum of angles in the parallelogram there is equals to 360 degrees. So in this case, we have 260 degrees minus 80. Knowing that if we name this as A, B, C, and D, so that angle C is also 40 degrees. So we have it at our 360 degrees minus 80. It will give us 280 degrees. So 280 degrees divided by 2 will give us 140 degrees. Will give us 140 degrees each. So that our angle B and our angle D, they are both 140 degrees. This is also 140 degrees. So these are the angles that we are going to use. So if you detach triangle CAD, that is angle CAD, you will have something like this. If you detach that angle, this is what you are going to have. We have that our F is here, our A is here, and our C is here, our D is here, and this is your 140 degrees. This angle is yet alpha is yet not given. We don't know it. And this angle too, we don't know it. But we know that here is 12 degrees, 12 Newton, and here is a 5 Newton. Good. So at this point, we are going to find F, the resultant vector, using the cosine rule, because the conditions for using cosine rule are met. Side AD is given and side DC is given, then an angle in between them is also given. So we write that our F squared, is equals to F1 squared plus F2 squared minus 2F1 F2 cos what? Cos D. At this point, we substitute. Please permit me to say something here very important. Anytime you are solving a physics question, it is imperative to write down the equation that you are using to solve that question with, because the equations also carries mark. So we know that our f1 is 5 square plus 12 square minus 2 into 5 times 12 times cos 140 degrees. If you evaluate that correctly, you know that your 5 square will give you 25 degrees. You also have 144 here minus 5 times 12 will give you 5 times 12 will give you 60, and 60 times 2 will give you minus 120 degrees times cos 120 cos 140 degrees will give you minus 0.76660. Always write this to 4 dp at least. So if you evaluate that correctly, you will have a 25 plus 144, and that will give us 169. Then minus this times minus this will give you a plus sign. So we have minus 120 times minus 0.7660. That will give us plus 91.92. So if you add them up, you are going to have what? That we have 169 plus 91.92. That will give us 260.92. So we write that our f squared times 1 all over 2 is equals to bracket 260.92 times 1, the index of 1 over 2, which is the same thing as the square root of 260.92. If we evaluate that correctly, our f is equals to the roots of 260.92, and that will give us 16.153. Therefore, our resultant force is given to be 16.153 Newton. So this force is given as 15.15. Let's stop there, Newton. The examiners did not ask us to find the direction of the vector, so we don't have to bother ourselves about that. So this is the answer. Next up, the examiners asked us to calculate the resultant force when the angle of inclination between the two vectors was 125 degrees. So that is the C part of this question. This time is an obtuse angle. We have this as 5 Newton, and that is our F1. And then the other vector is inclined in this direction. And then this is 12 Newton. And the angle in between the two vectors is 125 degrees. So we're gonna draw on this point of intersection of the two vectors. Let me redraw that again. Good. And then we are going to complete our parallelogram. Yeah, that's beautiful. So we know that if we name this as A, B, C, and D. So here is the force that we are looking for, the resultant force. So the parallel side are equal. Here is 12 Newton. And here is 5 Newton. So this angle we don't know. This particular angle here we don't know. This angle too, we know that this angle from angle B is 125 degrees. Angle C and angle A can be calculated from the sense of angle C and angle B. So that we say that our 360 degrees minus so angle B is 125, angle C is 125, and 125 plus 125 will give you 250. So we say that 360 minus 250 minus 250. If you do that correctly, you are going to have 110. So 110 divide by 2 will give you 550. So this particular angle D is 550 degrees. Angle A is also 55 degrees. So if you detach triangle BDC, which is what we are interested in, you're going to have something like this. Oh, that was not too wonderful. Good, something like this. So that this is your D and your D is 5 that. Knowing that side BD is a 5 Newton and side CD is a 12 Newton, and side BC, which is the resultant force, which is not given to you. This angle too, you don't know this angle, you have to calculate it at the end. This is called this angle gamma. So now the conditions to make use of the cosine rule are met. Side BD 5 Newton is given, side CD 12 Newton is given, and an angle in between side BD and side CD 55 degrees also given. So right now we proceed and apply our cosine rule by saying that our f squared is equals to our f1 squared plus our f2 squared minus 2 f1 f2 cos t. So if you look at this again, you have to substitute. Recall this is your f1 and this is your f2. So we say that our f1, which is 5 squared plus 12 squared minus 2 into 5 times 12 times cos what? Cos 5. If you evaluate that, you're going to have 5 squared will give you 25, and this 12 squared will give you 144, and 144 into 2 times 12 will give you 60, and cos 55 will give you 0.5. Let me do that again. This times cos 55 will give you 0.5736. Good. And then if you evaluate this correctly, 225 plus 144 will give you 169. So 169 minus 120 minus 120 times 0.5736 If you evaluate that correctly, you have that you have 169 minus 120 times 0.5736. That will give you six. That will give you 68.836, and you have 169 minus 68.836. That will give you 100.164. So we write that f square. We write that f square times the index of 1 all over 2 is equals to bracket 100.164 times the index of 1 all over 2, and this will go, so that we have that our f is equals to the root of 100.164. And if you find that root, you are going to have the root of 100.164. That will give you 10.008. Therefore, the resultant force when those vectors were acting at an obtuse angle of 125 degrees to each other is going to be 10.008 Newton. As simple as ABC. Next up, we are going to look at question number 2. Question number 2 reads, a body of mass 5 kg initially at rest is acted upon by two mutually perpendicular forces of magnitude 12 Newton and 5 Newton, as shown in the figure below. If the particle moves in the direction of QA, calculate the magnitude of the acceleration. Very simple. So what we're gonna do here is we know that this is QA is the resultant force, and then you have to complete this rectangle. Knowing that this side is also 12 Newton, and this side is also 5 Newton. Good. So let's proceed and solve the question. We have this. We have this as 12 Newton. We have this as 5 Newton. And then from up here, we complete the rectangle, sorry. Good. So here too is a 5 Newton, and here too is 12 Newton. And then this is a QA. And so we are interested with this. So the question asks us to find the acceleration. Note that again in physics is useless. We know that the acceleration of the body is given to be mass from Newton's second law of motion. from F is equal to mass times the acceleration. The mass of the body, where F is the resultant force that we are supposed to find, and A is what we are to look for finally, and the mass of the body is given to be 5 kilogram. 5 kilogram. So we have all the information needed right now. So what we are going to do here is because it's forces that are acting at 90 degrees to each other, or they're acting perpendicular to each other, we are going to apply Pythagoras theory to find the resultant force, which is this. Good. So at this point, we are going to apply Pythagoras theory, where we have it that the resultant force F squared is given to be 5 squared plus 12 squared. If you evaluate that correctly, take note of that. We have 5 squared plus 12 squared. So we have 25 plus 144. And if you add that together, you're going to have 169. We have 25 plus 144. We have 169. I was correct. So at this point, you write that. 169. At this point, you write that your F to the power of 2 times 1 over 2 index is given to be 169 times 1 all over 2 index, which is the same thing as the root of 169. If you do that correctly, you have that the resultant force is the root of 169, and that will give you 13 Newton. So at this point, we are free to apply F is equals to mass times acceleration. So we are going to make acceleration the subject matter. So this implies that ma is equals to force, and we divide both sides by m, so that m will cancel out m, and our acceleration is given to be the resultant force, which is the vector, divided by the mass. In this case, our resultant force was 3 Newton, and then our mass was 5 kilogram. So we're going to substitute this correctly by saying 13 Newton divided by 5 kilogram. If you do that correctly, you have it that your acceleration A is given as 13 divided by 5, and that will give you 2.5 meters per second square. Therefore, the acceleration of that body is given to be 2.5 meters per second square. As simple as A, B, C. Next up, we have question number 3, an applied question. Question number 3 reads, a boat travels due east at a speed of 40 meters per second across a river flowing due south at 30 meters per second. What is the resultant speed of the boat? Very, very simple. So let's have this as our north, south, east, and west. Let's add meaning to this question. A boat travels due east. The river is flowing due south. The river is flowing with a velocity the boat is also moving with a velocity. So we are going to represent this. Let's use this arrow that is going down to the east as an arrow to show the direction of travel of the boat. And we know that the boat was moving with a speed of 40 meters per second. So write 40 meters per second. Now let's use the second arrow to represent the direction of flow of the water or of the stream down south. The river flows down south 30 meters per second. Now recall that this arrow will not be long. This arrow will be short, will be shorter than the other arrow. And this is what? 30 meters per second. 30 meters per second is the direction of flow of the river or of the water. So we have succeeded in forming this. Now the resultant speed of the boat is this line. Yes, this is the resultant speed of the boat. So we can call this as our V1 and this as our V2. So applying a square is equals to b square plus c square, we are going to say that our v is our a right now. So we say that our v square is equals to v1 square plus v2 square. At this point, we substitute. Our v1 is 40. We have 40 squared, and our v2 is we have 30 squared. If you evaluate that correctly, you have 40 squared. 40 squared will give you 1,600, and then 30 squared will give you 30 squared will give you 900. And if you add this up, what you have 1,600 plus 900. That will give you 2,000. So we have that our v square is equals to 2,500. So v squared times the index of 1 over 2 will give you bracket 2500 times the index of 1 over 2. This will go. Your v is equals to the square root of 2500. So your v square is equals to the square root of 2500, and that will give you 50. Therefore, the resultant speed of the boat is given to be 50 meters per second. To this, we have come to the end of this particular video series. Subscribe, like, comment, and share. God bless you.